Perfect. So I'm Cedric Bail. I'm working for Samsung. Maybe it's a little bit too much. So I'm working for Samsung Mobile, and I'm working on TIZEN, and especially on the Composite Manager, and which is on TIZEN Enlightenment. So I'm going to speak a little bit about what is this TIZEN Composite Manager, what it does, and then I will spend my time explaining where we are going and where we are spending our time for the future. So it's absolutely not a talk about TIZEN 2.0 or 2.1. It's something that will be likely happening maybe for TIZEN 3. So it's R&D. Everything is done upstream, so that's why I'm very easy to speak with you about this subject. It's nothing, everything is done in the open, so makes life a little bit easier to talk. So after that, I will speak some where we are going and why we are thinking about using Wayland and going this way, why we do care about memory usage, and how we are going to reduce that by sharing more information across application, and also why we do care to have applications that start up fast and what we are doing in that regard, and why all of this thing will lead us to have some system integration even at the level of the Composite Manager. So what is the Composite Manager? So in TIZEN 2.0, it's Enlightenment 17. So Enlightenment 17, it is directly taken from upstream, so it's an open source project, and it has a few custom modules. So Enlightenment is very modular, and that makes life easy when you are integrating into a new device, because you can change only a small part of the code to fit into your device to make it sense. So it's really very close to what upstream is. And it's using Enlightenment Foundation Library 1.7. So it's a very old product. Enlightenment does exist since '97. It has been the version that we have been using now in TIZEN is a 0.17, has been under development for something like 12 years. We have not, well, the Enlightenment community has not seen any pressure to do release. So the release did happen because Samsung did and wanted it to have a stable base to build stuff on. So it was done last year in December, on the 21 December. And now we are moving on, and we are starting to work on Enlightenment 18. All the projects and the development is done upstream. It's a lot sponsored by Samsung, and many of the community has been hired by Samsung to work on it. So Samsung has a very good knowledge of what it is and how to drive it. But we still do all the decision and all the discussion upstream. So that is designed to make people still able to interact with us and be a meritocracy. And so Enlightenment right now and today is a window manager for X11. It is a composite manager also for X11, and it includes a file manager because, well, it was needed for some part, and we did increase the feature of it. So it has all the classic feature of an X11 window manager. It does on the virtual desktop. Like, it is the same thing you can get on a desktop. And all these features are available for an TIZEN device. So it handles also, well, it is something that is very interesting with Enlightenment. It was designed for the embedded world from the beginning. So it's very modular. Everything is in a module. So for example, the policy of how to place window on the screen, it's a module. So we have a window policy that is for phone, and we have some other policy for the desktop. And we have, for example, on the desktop, we have two policies. We have the tiling policy and the classic desktop one. So even on the desktop, you can change your own policy. That is how modular it was designed. That is really useful when you are doing all kinds of device, because TIZEN is not only for mobile phone, it can be also for TV, tablet, printer, camera, whatever. It's everything that Samsung can do, it may be one day a TIZEN device. So there was a need to have something very modular here and very easy to customize. Another thing that is also because we were targeting the embedded world is that the UI doesn't, we need something that is able to adapt to the screen size, and we don't have to take care about the reading distance and the pixel density and redo all the UI. And we also need to have something that takes into account automatically the size of your finger, because depending on how many, the density of the pixel and your fingers, the size of your own finger, you will be able to click on a button or not. So all EFL and Enlightenment Foundation Library provide to Enlightenment is a set of tools that is automatically scaling the UI, taking all this information of the pixel density, the distance, the finger size, to make the UI looks good and usable on your device, which is something that is make like magic, because you just configure it and then all your applications are ready to run with that. Another strong point is that in the embedded world, when you are trying to sell things to your customer are most of the time different operator. So you want to customize your UI to this operator. And you provide, in that case, different theme. But you don't really want to make a fork and have different source code. So you really need to have something that makes it easy to split the logic and the theme, so that you can easily switch and have very common base code between all operators. And for that, EFL provides us with a very split theme and logic system, which I will not spend too much time talking about because that's already what exists. Another thing is that right now we have so many devices, but most of the people think that we have a smartphone, we have always a GPU. That is great. We always have OpenGL, yes. But in fact, we don't. We have many devices where we don't have OpenGL. So EFL does provide software backend, and Enlightenment Composite Manager is able to work with the software backend and doesn't rely at all on OpenGL. It is not using a Mesa LLVM pipe implementation. It is a true software backend, which means that it's really performant. I mean, if you use it on a desktop, many Enlightenment developers did get confused and didn't see that they were using the software backend instead of the OpenGL backend. So it's really fast, and you need to be a little bit trained to make the difference and to see that there is a difference between OpenGL and software. So that is thanks to Enlightenment Foundation Library that provides this for free for Enlightenment, basically. We are using the same scene graph in the composite manager that we use in EFL. That is the same code. So we just build on it. We have all this optimization that come for free. And also, one other thing is that because we are developing Enlightenment and EFL together, they are cooperating. And this means that, for example, when the application is an EFL application and it's hidden, then Enlightenment can tell it that you can now throttle yourself. And the application will now go into very long sleep and do real sleep and not wait for anything. But Enlightenment will wake it as soon as needed. So even if it's sleeping, it will send a signal and it will wake up and it will be ready to run again. This is very important when you are doing embedded stuff because we want to reduce the battery consumption, and being able to cooperate between the window manager and the application to reduce power consumption is really something very important. And yeah.
What do you throttle?
The main loop. We just sleep the main loop. So the main loop block for depending on how you define stuff, but it can block for maybe like 1 second or 2. And the main loop will not exit the sleep because it's basically just waiting for this to go out. So there is no way to wake up the main loop, except if Enlightenment sends a signal to wake it. So this way, we are guaranteed that your process will not do anything.
And this is proprietary between Enlightenment and
yeah.
EFL library.
Right now, it's proprietary. We have the same thing of proprietary protocol for the reading distance, pixel density, and finger size. That's something that should be, at some point, we should be trying to do some standard about it. I was thinking more about trying to do that with Wayland, because that's where, I mean, the way we will be doing on X is we will add some property, and Toolkit will try to do it things. But I don't see much traction there. And well, everything is to define. So it's, I think it's something that we really need to push there. But I'm going to go to that. So using Tizen, well, so Enlightenment is window manager and composite manager. And all this R&D effort is done upstream. So all the features I'm talking about are already available upstream as free software. For Tizen, it has very few specific modules. Basically, the modules are here to do some optimization for the device. That is it's really useless outside of this device, one particular device. For example, we have some optimization to be doing direct path rendering, but that's very dependent on the driver, and we can't really make that upstream because it's just one device. And also the license on Enlightenment is a BSD license, so it's completely up to the manufacturer to upstream or not. And this also means that as upstream, if this kind of module makes no sense for us, well, we have no need to integrate it. So that is kind of a good thing. And so I'm going to focus on the upstream work. But first, I will just talk a little bit about some of its capability. So Enlightenment, the reason why Enlightenment was chosen by Samsung is that it was, at the time, the most efficient one. And still today, it is very efficient. So for example, if you take the Nexus 7, you have Ubuntu Unity on it that exists. And if you switch from Ubuntu Unity to having Enlightenment, you just win 200 megabytes. That's it. I mean, just removing the window manager and changing it, you have win 200 megabytes. It has a very minimal process model, so that's also saving. That's why it saves a lot of memory. And it does provide all the infrastructure for touch or mobile UI. It does handle multi-touch and things like that. And the thing is that it also doesn't reduce the feature. You have still a full desktop availability. You have all the features that you can think of on desktop. So it's really wide range. And it provides a lot of choice. So as our company, they really want to have something that is stable to build their device on. So we need to have a time-based, we need to have a release. And so the release of Enlightenment was something that has been, we didn't do any release in 12 years. So the joke is to say that we have been doing time-based release, one every 2 decades. The last one was in the late 90s. So this one is was last year. We choose the dates close to the apocalypse. So we can already, well, we don't trust anymore the Mayans. They obviously failed. So the next one, we are going to trust the computer science engineer. And so the next Enlightenment E18 will be, I guess you already know the date. And no, but just trying to do a joke there. We are going to really move forward to have something much more often released, so that people can build device every year on something that is much more strong. So we are trying to do Enlightenment 18 this year. I will say as soon as possible. So the target is before Christmas. Hopefully it will be during the summer. And one of the reasons, I still feel to justify that we did spend that much time on 12th year on developing a window manager. And the main reason is that it was started just as a file manager. And when we were developing this file manager, we did discover that we needed a toolkit that was able to have a scene graph. And we are in 2013 now, but 12 years ago, there was no scene graph toolkit. That didn't exist. So we needed to build something to do that. And that's why we did build very early in 2004 EVAS and this scene graph. And we have been building on it for the last 12 years. And it took us a lot of time to build this new toolkit. And basically, the last 12 years was spent on developing this toolkit that gives us the scene graph, does give us this clear cut between theme and logic. It does give us efficiency. It does give us something that is light and portable. EFL work on all Unix. It works on Windows. It works on Mac OS X. It's very easy to port it even on real-time OS. It was used on very small real-time OS, and it's something that you can port on any real-time OS in like 1 month if you don't have GPU. Because when you have drivers things, it kind of slows things down. But if you just use the software backend, it's something that is really fast. As soon as you are able to get a frame buffer, you can use EFL. So that is where we did spend the last 10 years. And all TIZEN and all Enlightenment are built on top of EFL 1.7. That is the latest stable branch that was released in September last year, if I'm correct. And so EFL is really what we are using for all these things. EFL provides various data type and other tools to build. When in C you don't have a very big library, the C standard library, so you need a lot of list, hash, whatever. So that's what ANA provides us. We also have it to do all this serialization thing, which is very useful for our theme and configuration. It's also very useful for storing data that you read really often. So instead of using SQLite, for example, for storing your cached data, I really strongly encourage you to use EET because that is way faster. It is a way to store C structure, and it's designed for that. EVAS is clearly the biggest thing. It is our scene graph that is doing software and OpenGL and OpenGLOS. It is really the core. I mean, most of the features come from it. That's what makes the difference. And eCore is what is your main loop thread. All this event thing is driven by eCore. The theming is in Edge. We have some free desktop standard implementation in Ifrit, and the widget set come from Elementary. We also have some support for video, audio, and other stuff. It is, well, yeah, it is a full toolkit now that you can write application on desktop, on mobile phone, whatever you want. That is where we did spend 10 years. So back to Enlightenment and TIZEN. So the question is more, why does Samsung continue to invest in Enlightenment? Because it's already quite good. We are always wanting to have something that is more secure because we are running native application. And for most of, I hope that for everyone here, it is clear that using X11, as soon as you have an X application, you have no more security. It's done. Any X application can be getting all the inputs. It can be getting the screen. There is no security with X11. That is something that is a problem when you're doing native application. That is one of the things that we want to address with the way we are going with Enlightenment. We also want to be always more efficient because when you are faster, you can use less battery and you have a long life phone, or you can reduce the cost. And we want also something that is more reliable and that is always giving the best experience to the consumer. And of course, we want to cover more devices more easily. So that is where we are going. That's why we are going to WLAN. So WLAN is a new protocol that is going to replace X11. It is a completely new architecture. It is something that it is really, well, I will still show slide later on the architecture of WLAN. But the main reason that we are interested in WLAN is it gives us security. First off, we will be able to have to handle native application and not have it stealing information from other. That is a key feature. We also, the way it was designed gives us better power consumption, so it will be more efficient to move to the WLAN protocol. I will come later to that. And so as not everybody will be able to move to WLAN in one day, we'll still have some mechanism to provide X over WLAN, which is very important. Currently, there is only one implementation, which is named Weston, and Enlightenment is trying to be a WLAN compositor. So it's not going to use Weston or WLAN compositor. It is going to be an implementation of WLAN protocol itself. EFL already supports Wayland, and Enlightenment does handle Wayland client. That is still mean that Enlightenment is still a X11 composite. So that is the next step. I will do some demonstration about these two features of EFL supporting Wayland and Enlightenment being able to run Wayland later on. So that is how X works today. The thing is that the compositor is not in the middle of the pipeline. So basically, all the event goes straight from X to the X client, and all communication go from the X server to the X client. There is no way for the X compositor to force the input to go to him first and then to be dispatched to the client. This means that there is no way for the compositor to be sure that the event go to the right place. And X client also has this awesome feature to be able to grab all the input at any time. So basically, even if you are the compositor, and even if everything was going through you with X, you can just intercept all communication. So that kind of mood. And with Wayland, it simplifies things by just removing X, basically. And the Wayland compositor does the job of what the X compositor, what the X server was doing. The thing is that, well, if you have any question, just don't hesitate to interrupt me and ask at any time. The thing is that in the past year, a lot of people in the Linux community have been working hard to make the graphic stack of Linux much more clean and much more easy to reuse. So today, with KMS and all this stuff, it's now very easy to build what the X server was doing before. And so it means that we can have this Wayland compositor that is implementing an X server, I would say, inside it much more easy than before. And this means that we are simplifying the code a lot in that side. So, and it's also something that is a big trend is that most applications in the past 10 years have been moving from using the X protocol to draw to just push Pixmap. So instead of using the X protocol gives you a feature like you can draw circle, you can draw font, you can draw image, and so on. But it is very slow. And it really depends a lot on the driver. So many toolkits have been moving away from using X to do the rendering to use their own software backend or to use OpenGL. That means that basically a lot of the logic that was inside the X server has been moved already to the toolkit, and the code in the X server was not used at all. So we can remove that part. It was basically just bloat today. And we use now just buffer. So the application just sends buffer to your Wayland compositor, and the Wayland compositor just know how to handle this buffer. It doesn't handle all this font rendering and so on. We simplify a lot of things in the compositor, and it also means that we can do a lot of more optimized work. So that is a screenshot of Enlightenment running Wayland, but I think I can just try to do it here. And of course, I am not lucky today. So I'm running a very, very latest Git version of Enlightenment to be able to do this demonstration. So I really do think it's completely broken. So it doesn't work that well. But anyway, so right now, all the windows here are X11 window, and everything is done by X11 protocol. But if we ask Wayland, so right now we have another window, and this one is different. You can see it already, but the title bar is not the same. The reason is that with Wayland, the title bar and all this thing is provided by the application. So right now, the application is using its own theme, and this one is not in synchronization with Enlightenment theme, which make it easy to spot the difference. So that one is a Wayland window running inside Enlightenment in X11. That is the first step to be able to start building application and to make it run on.
Where did you start the Wayland compositor? Or is that
it's Enlightenment.
It's the one that you had already running.
Yeah, Enlightenment is already Enlightenment now from Git is running Wayland. So You need to turn it on, but if you turn it on, it will be always there. And if you run an application that is only Wayland, it will be working.
And it's also at the same time an X window manager.
Yes, and composite manager. And you can have and that is all our test. And you can see it's kind of work, which is kind of cool. So that is elementary test, and this is another theme that is not the same as the default one of Enlightenment. So we really see the difference. And the toolbar is really different. So that is using Enlightenment. That is using Wayland. And that is an independent step because that means that we can now build application using the Wayland protocol, and we can use them under X. Yeah. Oh. The only problem with that is that the code is completely broken. Yeah.
You said that the window decorations are done by the applications, but done by the compositor, aren't they?
No, the window decoration are done by, when it's done by Wayland, it's done by the application. Yeah, each application provides its own decoration. It gives us some interesting feature because now if a Windows is maximized, it's basically one buffer that is only one application. So we can now, instead of using the GPU on the application side, we just need to, on the compositor side, we can just swap buffer, and we don't use the GPU at all on the compositor when we have a full screen application. I will go on later on this subject again, yeah, whatever. I don't know why that doesn't work anymore. That is nice. Yeah, good. So what Wayland does give us, does give us the same infrastructure. I was telling before that we have some custom module on Enlightenment, and these custom modules are basically designed to take advantage of the hardware to do a faster rendering path. This module is done per hardware. With Wayland, we'll be able to have the same optimization everywhere. That means that we can have better optimization because we can share more optimization across the device. So every time you improve one, you improve all of them, which is something that's really useful. Well, as I said before, it is more secure by design, which is absolutely needed. And it also opens a lot of room for optimization. The first thing it does offer is partial update per frame, and that is always the case. Something that is very important is that right now when you are using OpenGL for updating a window under X, if you don't have the right extension, it's just impossible. You need to redraw the full screen even if you have just one cursor blinking. So if you're doing a text application using OpenGL, you will be using a lot of GPU for just blinking the cursor, and that is just useless. So for example, right now, it is really costly to do a text application with OpenGL. It is much better to do it in software because of that. With Wayland, in the core protocol, we have partial update. That means that every application will be able to use OpenGL and just update the cursors that blink, which means that we will be much more efficient there. As I say, it works by exchanging buffer. So we have a lot of cases where we can detect and use the hardware, and instead of using the GPU on the compositor side, we can just switch buffer, which are much more efficient. Basically, the less you use the GPU, the less you use battery, which is something that is really care about. Another thing that's in Wayland, we can start to use layer. So many hardware are able to use 3 or 4 layers of buffer, which is sometimes you can have any kind of buffer. Sometimes you have some constraint, like you can only have some video buffer for displaying UV format, or you can have only 8-bit things. But with the time, we can have a lot of layers that we can reuse. And for example, if you have 2 layers, you can start to do optimization where the application that is on the top has its own layer. And usually, it's the only one getting update. So the compositor will have nothing to do for the layer that is in the background, and will just switch buffer on the foreground, which means that basically you will have one application that is not full screen, and will be able to have no use of the GPU for your compositing. That is also a big win, because you are now able to have a multi-window thing and use the GPU only in a very limited case. You are saving battery again. By having direct access to the hardware, that is all the kind of thing you can do. By having access to the layer, we can also improve scrolling. We can do scrolling for maybe 1/10 of the GPU and CPU power we use today, because you are again manipulating the layer, so you just move your layer instead of rendering it all over the place again. This is the kind of thing you can really win. So that is why we are looking for Wayland. It opens a path to a lot of optimization, and we can win something, an order of magnitude thing we think there. So right now, EFL is something that is like 10% with X11. It's 10% below Android consumption. So with Wayland, we are going to have something that can be an order of magnitude faster and another order of magnitude more efficient and less battery usage. Or you can change for a smaller system on chip and get the same result. That is something that is really interesting. So right now, what we are trying to do, the road to get there. So we have already added the software and GL Wayland back into EFL, so you can start writing. Well, basically, you still write EFL application, and you have nothing to do in your code, but just one variable to change in the config, and every elementary application will become a Wayland application. We have now support for Wayland client in Enlightenment, so you can start testing it and be sure that your Wayland client, that is maybe not an EFL client, will be running fine there. We have also been doing a lot of cleaning up in Enlightenment itself to simplify. Before, Enlightenment was able to be in 2 modes, which is having the compositor on or off. Right now, we are removing the off, and we are always on. And we are doing a lot of optimization thanks to that, and it simplifies our code a lot. It's also why it's a little bit broken right now on my laptop, because all this code is moving a lot at the moment. It will simplify things a lot. And we are going to add a Wayland KMS backend and a Wayland FBCon backend compositor to Enlightenment. This way, you will be able to test it on much more hardware than we can do today. We even think we can make a Wayland XPix map, because Wayland doesn't define what a buffer is. So you just need to agree on it. And this can open some door to basically use an NVIDIA proprietary driver. And the driver, you will be exchanging XPix map buffer instead of using DMABuf. So there is some possibility to do this kind of thing with Wayland. And that is really interesting. And the next step will be to start optimizing. As when we will have all this stack built, we will be able to optimize and do things. So we believe that for the end of the year, we'll have all the Wayland implementation done, and we will be able to start all this kind of optimization next year, basically. By simplifying our compositor code, what we are doing is that when you had, well, before, all the window, all the menu, the background were in its own X window. And the compositor was getting all this window and making compositing. This costs a lot of memory, because basically you are duplicating the resource 2 times. And we have now removed the need to use this X window, and everything is done directly in Nevas canvas. So all the menu, all the icon, everything is done directly in Enlightenment. It doesn't go to X at all. That is needed to go to Wayland, and it also gives us some memory reduction. That is basically making Enlightenment use the same amount of memory without a compositor than with, which is a good point. We have been also doing optimization in EFL to reduce this memory usage. And one of the reasons why we care about memory usage is that every time you use memory, you use battery. So we are trying to reduce the memory usage to reduce the battery usage, basically. It also means that we can shut down part of the memory more dynamically.
I don't think the kernel does that yet.
There was a patch last week by Samsung for the Exynos that does that. So, yeah.
Yeah, I mean, most systems you can't do that, so only if you reduce the amount of memory that exists in the system.
Yeah.
But then you still need to reduce memory usage.
Yes, you still need. Well, the first thing is that if you use memory, if you go from every layer of cache, use more power. So if you stay always in L1 cache, you use less power than if you go in L2. If you go in memory, it's even more than if you stay in L2. So the less your application use memory, the more likely it is to be on L1, and the more likely it is to use less memory. That is the first thing. But after that, we have also some optimization on the hardware side because Samsung basically does also hardware. And there was being some patch to basically be able to shut down part of the memory. And by using less memory, we give a chance to the kernel to shut down part of the memory, which is kind of good win. What also we can do to reduce memory is to share more data across application. So right now in EFL 1.8, so the one that you are working on, we have been working on a server that share image and font across application. So that is something that already works. It is upstream things. That means that basically when you are starting an application, it uses the same buffer as the one that has already been started. That is, I mean, you have a lot of image on the screen, and everyone's image is quite big, and that can be shared because it's the same theme in all applications. So no need to decompress it 2 times, no need to open it 2 times, and no need to waste CPU and memory for getting 2 times the same thing. We also have, we are trying to share more stuff during initialization of application. Basically, we have, I will speak later on, but we have a Quicklaunch thing that make parallel initialization and share library across things. So Eva CServe is this server that share image and font glyph and geometry. By moving to Wayland, we could be starting to share Wayland buffer directly. So we'll not have, right now we need to upload 1 texture per application, but later on with Wayland we should be able to share the same texture across applications. So that will be even reducing memory usage. CServe2 is also improving our stability and security by running decompression of image in a child process. So if it crashes or has any issue, it will not bring down your application at all. And by having less data to decompress at startup, it makes your application start up faster. That is kind of obvious to say, but it is a win. So basically, by reducing memory, we have achieved another goal that we wanted to have, is to have applications start up faster. So one of the current limitations of this idea is that we have no cooperation with the kernel. Basically, we are implementing a cache system in the user space, and we have no idea of how much memory we can use for this cache. So right now, it's hard-coded in the cache. One other thing that will be really interesting to test is to have a cache FS and to integrate with the VFS cache system. This way, we can have a way to basically throw away resource when the kernel thinks it's a good idea. And we can tell the kernel that we have some buffer and what files they are linked to and how much time it does to decompress them and how much we use them. And so it could be a file system that comes from TMPFS and that is doing this kind of thing. That is really R&D stuff. That is, I think, worth trying it, but there is we have no idea if it will be helping at the end. So what does make an application startup faster? An application startup is kind of easy. It links to the library it needs. Then it initializes the toolkit and connect to X, read the configuration, load the theme, create the window, and load image data, and then you have your first frame on your screen. By having CServe2, we have basically almost removed load image data. But we have still a lot of things to do. So we have this tool that is named Elementary Quicklaunch, which basically does a prelink and also does partially initialize the toolkit. Right now, it doesn't do the connection to X, nor the configuration or the theme loading, because we can have a theme that is changing per virtual desktop. So it's kind of much more tricky than we think to do that. But it is something that we are looking forward, because basically we are right now with that Quicklaunch, we win something like 20% of startup time for an application. And if we can remove the connection to X, the configuration, and the theme loading, we can maybe win 50% more. So right now, when we spend time in reading configuration, opening theme, and also all the dialogue with X, basically to get the window created and things like that. Yeah, that is just a number of starting well on Quicklaunch and on for some game we are doing. So we do that on a Raspberry Pi. Yeah. So yeah, that's what I've been talking already. So yeah, I have already said that, in fact. So Elementary Quicklaunch is not, it's provided by Elementary. It's a server right now, but it's a set of API, so you can reuse it in your own device the way you want. It's basically what Samsung does. Samsung has been integrating Elementary Quicklaunch inside App Core. So that's something that is hidden to the developer on Tizen, but basically we do already use it. What we can do maybe in the future is to integrate Enlightenment to directly connect to Quicklaunch and do all that without the need of an external library, an external tool, which will make applications start even faster. But that's very small optimization. And one of the things is that we are adding more daemon, basically, because we have the CServ2, we have Elementary Quicklaunch, which is its own daemon, EFM, which is a file manager daemon, because all file access need to be kind of safe. If something crashes on the file system, you need to not crash your window manager, so it's another daemon. We have eScanner, which is scanning for connectic and stuff like that. We have tempget, batget, which are also daemon to get temperature and battery without the need to be root for Enlightenment. So we also have Elevate, which is a JavaScript daemon that is pre-initializing V8. And we have, and Enlightenment itself is currently monitored by Enlightenment Start, which is a lot of daemons are around the place. So all this logic to monitor all this daemon is currently in Enlightenment Start. It's a very simple logic. So it's not optimal, it's not reliable, it's very simple. It does the job, but it doesn't offer all the features we can think of. And right now, there is something that is called systemd. And systemd does manage daemon quite well. It's its job. And there has been a lot of work from, especially Intel, to have a systemd user session. And basically, the idea is that you use the same infrastructure that you use to do your initialization of your system to initialize your user session. And you can use all the features that systemd provide to you for the initialization to do the monitoring of all these user daemon. So you can have socket activation. So basically, the CServ and the Quicklaunch will be started when needed. We can get a lot more reliability because we can do watchdog, we can do dependency handling, we can restart the stack correctly if one of the daemons goes down. That's offer a lot of, it improves the whole stack. And it's the thing that is, we could try to put that in Enlightenment Start, but it will be a huge work to do, and it will be a duplication of the effort already done in systemd. So that's why I think that Enlightenment itself and Tizen will be moving forward to look at systemd because it really offers a lot of nice features. It also improves the security infrastructure, and it's also really adapted to embedded world. I mean, it reduces all the script. There is no more script to be run during the boot and all this thing. It really makes life easier there. So systemd, for the people that don't know what it is a service manager for Linux. It does handle your initialization of your system, basically. It provides aggressive prioritization. That means that when you are starting up, it is able to notice what process can start at the same time and just run them. So if you have multiple core, you are able to start much faster, which is kind of the case in the device we have. It provides socket activation, it tracks process, it can give process some resource limitations, it can change the security. It really provides a lot of, it offers an infrastructure to be reliable and secure, basically. And the user session is basically what takes care of starting X and all the things that come with it. Later on, it can also start Wayland, basically. It's the same thing. It's controlled by the user, so you have a few files that you can modify. And it's really straightforward for auto login sessions. So basically, the case for smartphone where you have only one user, it's really straightforward. It goes directly to do the auto login. And also, what is interesting is that the units that describe your project can be shared across distribution. Most of the time, the script, the initialization script need to be done per distribution because they are all of them very different. With systemd, we have now an offer to have something that is the same across all distribution. So we can do that upstream. This simplifies a lot of things because many distributions didn't understand how to do this optimization and correctly initialize everything. So providing units make life easier. And yeah. So we have already done our systemd integration in EFL. So we have automatically detect the system notify bus. We can push logs to the journal of systemd. It's done magically for you. You just use a now log infrastructure and you go to journal if that is available. You have nothing to do. It will automatically notify systemd when the main loop is running. So it detects that it is monitored by systemd, and it will tell systemd, OK, I'm running now. Everything is done. Initialization is done. I'm ready. It can also detect automatically the watchdog of systemd, and it will set up the timer for you. You have nothing to do. You just set up in your unit that you want a watchdog, and it does that for you. And we also provide socket activation. With just one flag in EcoCon, which makes life easier to write daemon that will be watching socket. So the ground to experiment systemd was done first on Elevate because it's less risky. And now we are just starting to integrate it with Enlightenment. We will still forever skip Enlightenment start because sadly not everyone is moving to systemd. So we need to keep it upstream. It will make our life easier for the ones that have systemd. And it should make also the startup faster. Right now on my laptop, I am really using systemd user session with Enlightenment Git. It's basically the setup I'm describing here. So it's already half working, I'll say. There is still some work to do. We have some integration to do with systemd login. We have to take advantage of the inhibitor lock, which basically make our application able to know that we are going to go into suspend, and every application can then throw away all the cache it doesn't need, giving a chance to the kernel to disable, to have less memory to use when doing the suspend, making the suspend more efficient. That is the kind of thing we need to do, but we have not yet done. So that is the road we are going to we take now with Enlightenment and EFL. We are already pretty efficient, but we are still wanting to be lighter, faster, more efficient. We want to be easier to integrate. So that's why we are streamlining things with Wayland and systemd that offer really something that will work across device, across distribution more easily. And it should provide something that is also more reliable. We should be realizing EFL 1.8 around 8th of May. We have already done a lot of improvement into our infrastructure. So we have continuous integration. We are doing unit tests, test coverage every day. We have more benchmark and tests right now that make sure we don't really miss things. And it's also now easier for people outside of that are not very trained to contribute to Enlightenment because we are using now Git and Fabricator. It makes really life easier to provide a patch and get it up very fast. And we are going to switch to a time-based release for EFL. and try to do 3 months or so between release. So we will have 1.9 something in September if everything goes correctly. So it should make life easier for people to join and help us. So we'll focus on Enlightenment 18 now, and to have this Wayland thing. A lot of people at Samsung will start working on Enlightenment Wayland starting next month when EFL 1.8 is done. It is something that is very important for us because we will be able to have an order of magnitude more power efficient things. We also need to focus more, because EFL is kind of a difficult thing to handle. We are going to try to have some rapid development environment for it. And we are going to try with Elevate and Node.js to have a JavaScript binding that will make life easier when you are doing an EFL application, basically. That is where we are going as the Enlightenment project. So, any question? I've been running quite fast at the end because, yeah, I am on time.
Questions you answered during the session?
Yeah, I have a TIZEN device. I was planning to give it to someone that asked question, but people from Intel are not subject to that win. So if you want to get this TIZEN device, you need to have a good question.
How the releases? So why you guys decide to change to time-based releases, and how does that connect to relates back to Samsung's product?
We are moving. Well, the thing is that Samsung really want to have a lot of feature very soon, and that means that we need to be able to push feature very often upstream. So the problem with having a long time between release is that you can't really have the product switching to a new release in the middle. So by switching to a time release that is much more shorter, we should be able to provide Samsung with new feature much more faster and things that are more stable, and we can. Well, basically, what we will be doing, we'll have a stable release every 3 months, and when TIZEN take one of these release and use it in product, we'll switch for this release on a long-term support and do backport on it. So basically, right now, the 1.7 is a long-term. It will be a few years of support on it because we will have it on a device. And 1.8, maybe 1.9, maybe 1.10, I don't know which one, will end up into TIZEN 3.0 and into a product. And then we will have to do long-term support for it too. So, but by moving fast, we are trying to be able to provide Samsung with a new set of features very often that they can try on their hardware, and we can have a better cycle there.
For a vendor's graphics stack, for this implementation of Wayland, what is required for the KMS?
Actually, yes, you should be. Well, the way it's done upstream for Wayland is to use KMS, but right as I say, there is nothing that defines what a buffer should be. So you can implement Wayland on just a frame buffer, but you can also implement it on GR-alloc, the Android buffer. Some people from last week did demonstrate that with Libibris and Selfish OS. So they are able to use an Android driver and have a Wayland stack on top of it, and things will just work. So the way we want to go is still to have KMS driver because it makes life cleaner and easier. But we should be able to adapt to a lot of possible driver because we don't have this definition exactly of what a buffer is. Any other question? No? Okay. Thank you very much.